Today we're going to talk about infinite limits. Now you studied asymptotes in pre-calc, and you know to look for asymptotes in the denominator of a rational function. So if we had 1 over x minus 2, we know that there'd be a vertical asymptote when the denominator is equal to 0. So that's when x minus 2 equals 0, so at x equals 2. Now here's a graph of that function. This is f of x equals 1 over x minus 2. And you can see here this is the vertical asymptote. This is not a part of the function. This is the asymptote. So the function follows along this way and goes down all the way towards negative infinity. And if we look from the right, our function is going up to positive infinity. So we can really talk about those as one-sided limits. We can say that the limit as x approaches 2 from the left is equal to negative infinity. And that as x approaches 2 from the right would be equal to positive infinity. Now we know that this means that both of the, or that neither of these limits exist, but we can be more specific and talk about which direction our function is headed if it has that unbounded behavior. Now the question is, what do you do if you're not looking at a graph? Well, here's our function, and let's say we want the limit as x approaches 2 from the left. Now we already know that that would be negative infinity. But the way that we look at this numerically is by comparing the numerator to the denominator. So here we have x minus 2. Now we're considering values of x that are less than 2, from the left of 2. So if we take numbers that are less than 2 and subtract 2, those numbers would be negative. Now in the numerator here we've got 1, and that's going to remain constant and always positive. So from the left of 2 we're going to have positive values divided by negative values, which would be negative values. So that tells us that this limit would be equal to negative infinity. And if we were looking from the right, I'm going to rewrite my function. So that is the limit as x approaches 2 from the right. From the right of 2, our x values will be larger than 2, and numbers larger than 2 minus 2 will be positive. And 1, again, will always be positive, so we'll have positive values over positive values, which gives us positive values. Okay, one more example. Let's consider g of x, a rational function. Let's have x over x squared minus 9. And let's say you were asked to find the limit as x approaches 3 from the left. Now we know we're going to have a vertical asymptote here because when x equals 3, our denominator is equal to 0. So when x is to the left of 3, we're going to have values that are smaller than 3. So numbers that are smaller than 3 squared minus 9 would be negative. So we have negative here. And then as x gets close to 3 from the left, and again we're talking about being close to 3, these values will be positive. So this would be equal to negative infinity. Now let's consider this function one more time. Except as x approaches 3 from the right. From the right of 3, this will be positive. We'll have values that are larger than 3. Numbers that are larger than 3 squared minus 9 will still be positive. And positives over positives give us a positive infinity. And here's our graph. This is x over x squared minus 9. You can see our two vertical asymptotes here, one at negative 3 and one at x equals 3. And as x approaches 3 from the left, g of x is definitely going towards negative infinity. And as x approaches 3 from the right, g of x is going towards positive infinity. So if you have a vertical asymptote, as x approaches that vertical asymptote, your function will either be going towards positive infinity or negative infinity. Now we can figure that out two different ways. One way would be by inspecting the graph, or we can look at our function numerically and compare the numerator to the denominator. So if your signs are the same, that is that the numerator and denominator give you either positive values or both negative values, you know that your function is getting closer and closer to positive infinity. But if you find opposite signs, then you know your limit is getting closer and closer to, or your function is getting closer and closer to negative infinity.